want to welcome you all to the Las Vegas Implant Direct Teaching Center. Today I'm going to be lecturing on a full range of subjects covering the implant industry, the last 30 years, where we were, where we are now, and where we're going, and talk about all the application-specific implants from Implant Direct. Implant Direct is the value player in the implant industry. Warren Buffett said, "Price is what you pay, value is what you get," and that's what Implant Direct is about, and really it's what I have been about for the last 30 years, starting with Corvent, Paragon, Implant Direct, and now Implant Direct Cybron. I have 35 patents in the field, and I want to share with you the latest product line and product innovations from Implant Direct. Here are 3 covers of journals showing our products. This shows all the different platforms that are available from Implant Direct. The 45-degree lead-in bevel on our legacy line was first developed in 1986. It's still on the Zimmer implants, on BioHorizons, on MIS implants. It's licensed to many of these companies. Here's the tri-lobe implant developed by Nobel, actually developed by Axel Kirsch in Germany. We make one that's compatible with that platform. We have a Straumann compatible internal octagon implant that I licensed in 2000 to Straumann. We have an external bevel SwishPlus and SwishPlus line that we'll be talking about. External bevel, internal hex. We will be launching an internal conical connection that is compatible with Nobel Active. The lead-in bevel of the legacy is a conical connection also. That just means that there's a lead-in bevel to provide lateral stability. We have 2 specialty implants, one-piece implants for specific applications. The Go Direct has a locator compatible platform for overdentures, and the Screw-in Direct has a multi-unit abutment. That means you would only use it when you're splinting 2 or more implants. These are one-piece implants. The new interactive implant that's yet to be launched with the Nobel compatible platform is shown on this cover. There's an article written on that. It has unique packaging, which I'll be discussing. Here's an editorial that I wrote on implant prosthodontics, past, present, and future. And really, implantology is a prosthetic discipline with a surgical component. Going back to 1982, you see the first Corvent ad. And here's some clinical pictures of Corvent implants from another ad. Used freestanding as a distal abutment to a 3-unit bridge. Freestanding to stabilize an overdenture. The Corvent was the first implant ever to take on this type of restoration. It's now become minimum standard of care by the American College of Prosthodontics. Multi-unit abutments with bars splinted that cantilever back for total implant support, and then angled abutments for full arch restorations. These were all in the 80s, part of the Corvent system. Here's a 27-year follow-up of a Corvent case. We used to leave the implant 1 millimeter above the bone when we buried it under the soft tissue, so it'd be easier to find. So these implants have lost about 1 millimeter of bone, and this one none, in the last 27 years. Hollow basket screw implant with a hex hole that accepted cemented restorations. In 1986, I developed the internal connection, lead-in bevel, internal hex. Used a body that was compatible with the Brånemark screw implant, 3.7. Going internal allowed me to make the neck narrower, 3.5 initially, then we strengthened it to 3.7, whereas the 3.7 Brånemark implant flared to 4.1 and needed countersinking in order to get it flush with the bone.
The screw vent evolved over the years, different lengths of neck, minor changes, different sizes to the vents. And in 2000, we had the tapered screw vent, put an even taper, gentle taper on it. And the advantage of that was that you could insert it in soft bone into an undersized socket, expand and compress the bone as you were screwing it in, and increase initial stability to try and equalize the success between soft and hard bone applications. I received a patent in 1990 on this connection, and that stood for 17 years and has become the cornerstone of modern implant design. Now, when I made the tapered screw vent, I knew that you didn't need a vent on a tapered implant. With the straight implants, the first couple of threads start to cut the bone and you need a place to throw the bone chips. But with a tapered implant, that apical end doesn't touch until you're finally seating the implant and using a step drill that cuts a smaller hole in the apex. But I left the vent in the tapered screw vent because I realized screw no vent would be a bad name for a product. But none of the implants we make today have vents in them. Here is a article that I wrote in 2000, Achieving Osseointegration in Soft Bone, the Search for Improved Results. And that was all about increasing initial stability by placing a tapered implant into an undersized socket. And we added double and triple lead threads, which means that the threads start 180 degrees apart and wind around the implant so that each turn drops the implant twice as far as the pitch between adjacent peaks of threads. This video will demonstrate that point. So assume that this is soft bone and this is dense bone. In the spongy bone, you would go in with a 2.8 drill that steps down to 2.3 and then insert a 3.7 implant, which will compress and stabilize the implant. That's been demonstrated to have a higher percentage of bone contact by putting that bone under compression. In dense bone, instead of using a bone tap to first cut the threads, after using a 3.2 drill, we just use a 3.4 drill with only the tips of the threads engaging and screw the implant in self-tapping. So anytime you can eliminate surgical steps, you increase your chance of success and reduce your chair time. Two marketing books that I've read, Differentiate or Die and Eating the Big Fish. This first one, Differentiate or Die, tells you how companies try to create some unique feature and then market it as if it were the most important thing in the world. Eating the Big Fish says how guerrilla marketing of smaller companies can eventually eat at and maybe destroy the premium priced products in various industries. So we have a variety of different companies out there, from Nobel, Astra, Straumann, and 3i and Zimmer, and they all have their unique selling features. The Nobel Replace with its tri-lobe, then they introduced the Nobel Active with a internal bevel, internal hex implant, very aggressive threads. We'll talk about that one. Astra claims that its micro threads reduce crestal bone, and they demonstrate that by comparing it against 25-year-old external hex implants that required countersinking. Now they've come up with a new profile implant, they call it, a tapered top. We'll talk about that, but that's to differentiate again. Straumann differentiates by packaging their implants in sterile saline and claiming they get faster healing with that hydrophilic surface that they create. The fact of the matter is that they've missed the point. The point is, how much initial stability can you get so that you can immediately load, not how much torque it takes to unscrew an implant at the 4th week. So Their implants are straight with minimal threads, and they can show studies with higher percentage of bone contact or torque at 3 to 4 weeks, so that you could load it earlier, but there's nothing earlier than immediate, and that's what you want to be looking at. When they finally made a small diameter implant, they realized they had to get away from pure titanium. So they came up with an alloy, but didn't want to just come up with the same alloy everybody else was coming up with. So they came up with one that had zirconia mixed to the titanium, which makes it more brittle, called it rock solid, and that's their unique alloy. You have 3i, which is all about acid etch surface, which frankly are too smooth. I stopped making acid etch surfaces in '92. And Zimmer with their trabecular metal porous surface, and that implant has its limitations. So what is Implant Direct's unique selling proposition? Quality, innovation, compatibility, selection, service, and value. We were rated the highest in customer satisfaction of the 7 premium companies through a Millennium Research report. We have the broadest selection of implants, compatible with popular industry implants such as the Nobel Trilobe, Straumann Octagon Connection, and Zimmer MIS BioHorizons lead-in bevel connection. And then we have some implants that are unique to ours, and we'll be talking about those. Here's an article that just came out October 23rd, analyst report, dental implant update. Between a rock and a hard place, disruption is here. And I was interviewed by this Michael Youngling, and I used that expression, between a rock and a hard place, and lo and behold, it appears in a report. And it talks about the loss of growth of the major players, and it tries to explain the innovation curve. From 1980 through 1990, and then the innovation that came along, supposedly, and then how the market is flattening out. I created a timeline to show how Implant Direct fits in. So the Brånemark implant, first titanium screw in 1965. There were other screws. He could not get a patent on his design because in France they had 2-stage screw implants, but he commercialized it in '78, launched it really in '83. I launched the core vent in '82 with a wide variety of abutments, the screw vent in '86. Core vent introduced the first sterile packaging in 1989, 90. Nobel was still telling you to clean your implants in acetone and alcohol and sterilize them when we launched sterile packaging. Then the report talks about technology improvements, rough surfaces, implant body shape, platform shifting. Well, here's a picture of a core vent implant with cemented posts. So you might say that's platform shifting. Back in 1982, and we had an aluminous oxide blasted surface that was washed with acid, so there's nothing new under the sun there. Implant Direct in 2006 launched the value segment of the market, and the majority interest was sold to Danaher in 2010. So this is an ad that you see quite often in the journals by Implant Direct. Tired of price increases on overpriced implants? It's time for a reality check. Choose Implant Direct for innovative products, great value, highest customer satisfaction. And there's reference to that Millennium study. And then it shows the price comparison, our list price versus the competitors, with our implants having all-in-one packaging, including transfers, abutments, healing collars, cover screws. We just add up those component costs. For Straumann, we have the SwishPlus implant and the SwishPlant implant. We use the SwishPlant here to compare because it has an abutment as part of its packaging, but comparable components from Straumann are $699. Our reactive implant compared to Nobel Replace implant or Nobel Active implant is a huge difference of $494. These are QR codes. If you scan this with a smartphone, you'll get right to our website and be able to watch the videos. And I'm going to show you two videos now, just 4-minute videos that we put together to compare these implant systems. So the first one is a reality check video for the Nobel Replace implant.
Implant Direct continues to provide a reality check to the implant industry by providing dentists with better products and better value, including the RePlant implant with both surgical and prosthetic compatibility to the Nobel Replace at a fraction of the cost. The RePlant includes standard all-in-one packaging, saving Nobel Replace customers $359 per implant. RePlant implants are made from medical-grade titanium alloy for greater strength compared to commercially pure titanium. The use of this stronger material and the fixture mount packaging significantly reduce the risk of fracture during insertion. RePlant's patented mini threads with double lead threads are designed to reduce crestal bone loss and speed insertion. These features, in combination with the long self-tapping groove, increase initial stability. Versatility is key, and by providing a multi-use fixture mount, the RePlant offers multiple insertion options and flexible temporary prosthetic solutions. RePlant's fixture mount with a flat side makes indexing straightforward, allowing for more common use of stock abutments. Implant Direct's use of the dual grip technology in the prosthetic screw, included cover screw, and available healing collars provide Nobel customers the added savings and ease of using their current tools. Only Implant Direct provides a natural solution for implant team communication issues by offering the team approach. With labels, standard letters, included impression options, and instructions, the smooth communication of the placing specialist, the restorative clinician, and the lab is achieved, providing the patient the most efficient care. With a full line of tri-lobe compatible prosthetics offering significant savings, Implant Direct continues to broaden your prosthetic options.
I want to show you the comparison between the SwishPlus and the Straumann implant. This is the Straumann implant, no vertical cutting grooves, very minimal threads. The SwishPlus is 100% compatible surgically and prosthetically and has added micro grooves. And we also have the SwishPlant, which is a tapered implant. So now I'm going to play you the reality check video that we developed to show the comparison between the SwishPlus and the Straumann tissue level implant.
The SwishPlus implant with both surgical and prosthetic compatibility to the Straumann ITI tissue level implant provides a reality check to Straumann customers by providing an improved design and packaging at a fraction of the cost. The SwishPlus includes a cover screw and a 2mm healing collar, saving Straumann customers $336 per implant compared to Straumann's U.S. list price. The SwishPlus provides Straumann doctors the same popular diameters and platforms they're used to and adds a narrow 3.3 implant and a 5.7 with a standard 6.5 platform, ideal for molar extraction sockets. SwishPlus provides the standard internal octagon Straumann platform with the addition of an internal square to allow engagement of a fixture mount to simplify implant placement. Microgrooves increase surface area and reduce stress on crestal bone, while the half-texture neck facilitates tissue-level or aesthetic placement. Progressively deeper threads increase surface area, and in combination with the apical thread and vertical cutting grooves, self-tapping insertion increases initial stability, so important for immediate loading. The SwishPlus implant's frictional fixture mounts and abutments offer 100% compatibility with Straumann surgical drills and tools, including both manual and motor-driven. Due to the half-textured neck, SwishPlus can be placed at 1 or 2 millimeters above the bone. SwishPlus indexing eliminates the need for Straumann's A or B two-piece abutments for rotational positioning by providing dots on the fixture mount that indicate the flat of the octagon. Internal flats are positioned at the time of implant placement, avoiding complications of A or B positioning. The SwishPlus fixture mount engages the implant's internal square and is frictionally retained for less complex removal compared to Straumann's fixture mount that only engages the internal threads and requires use of a holding tool to remove. The holding tool must provide counter torque to avoid unscrewing the implant. The inclusion of a cover screw with a 2mm healing collar, along with a shorter machine surface of the SwishPlus, facilitate flexible placement options, including tissue level, in thin or thick tissue, and aesthetic placement for subgingival margins. Implant Direct's solid straight abutments designed for snap-on transfers indicated for multi-unit restorations are provided in kits with significant cost savings compared to Straumann. SwishPlus also offers a kit with a two-piece abutment, snap-on transfer, abutment analog, and castable coping for single-tooth restorations in the posterior arch. Implant Direct provides free patient labels to facilitate team communication between the surgical specialist, restorative dentist, and laboratory. Implant Direct has Team Approach video links and customizable referral thank you letters available on the Team Approach section of the website. With a full line of internal octagon-compatible prosthetics offering significant savings, Implant Direct continues to broaden your prosthetic options. Watch the All Over 4 video on the support page at implantdirect.com to see GPS and SwishPlus used in an upper edentulous jaw treatment.
So now I'm going to play you the reality check video that we developed to show the comparison between the Zimmer and the Legacy 1, 2, and 3.
The Legacy system, with both surgical and prosthetic compatibility to the Zimmer tapered screw vent, provides a reality check to Zimmer customers by providing improved design and packaging options at a fraction of the cost. The Legacy implants are available with an overall textured surface created by blasting with HA particles called SBM or soluble blast media, or with this surface just on the top 3 mm with HA coating below. All Legacy implants provide the same platform designed by Dr. Niznick for the screw vent implant in 1986. Legacy abutments are compatible with the Zimmer, BioHorizons, and MIS internal hex implants. The Legacy implants offer color-coded anodized fixture mounts, platforms, transfers, and analogs to simplify ordering and use of restorative components. The new Legacy 1 implant features a frictional carrier for economy and ease of insertion. It has standard V-shaped threads, like the screw vent, while offering an SBM surface to the top of the implant versus the 1 mm machine neck on the screw vent. Legacy's double lead threads for faster insertion transition to micro threads for increased surface area and stability. The Legacy 1 has 2 long cutting grooves and an evenly tapered body to facilitate self-tapping insertion, compared to the 2 short grooves of the screw vent, with its apical vent that reduces thread engagement. Both surgical and prosthetic compatibility are achieved. Legacy 1 provides matching diameters and lengths to the tapered screw vent system. The Legacy 2 implant features a titanium fixture mount that functions as a closed tray transfer and can be modified for use as a temporary, engaging, or non-engaging abutment. Its body has double lead buttress threads that get progressively deeper apically for increased surface area compared to the standard V threads of the tapered screw vent. Zimmer Dental now offers an optional screw vent with an HA blasting to the top with microgrooves, whereas the Legacy implants have patented micro threads for added bone engagement. The Legacy 2 has 3 long cutting grooves and a more pronounced body taper compared to the tapered screw vent, with its 2 short grooves and an apical vent that reduces thread engagement. Legacy 2 maintains surgical and prosthetic compatibility with the tapered screw vent. Legacy 2 expands treatment options by offering a 7 mm diameter implant with a 5.7 platform, with a 3.2 and a 5.2 diameter implant soon to be added to the line, as well as 6 mm lengths. The Legacy 3 implant features a titanium fixture mount that functions as a closed tray transfer and can be shortened for use as a final abutment. Its body has double lead buttress threads that get progressively deeper apically for increased surface area compared to the standard V threads of the tapered screw vent. Zimmer Dental now offers a screw vent with an optional HA blasting to the top with microgrooves, whereas the Legacy implants have patented micro threads for added bone engagement. The Legacy 3 has 2 long cutting grooves and an evenly tapered body to facilitate self-tapping insertion, compared to the 2 short grooves of the screw vent, with its apical vent that reduces thread engagement. Both surgical and prosthetic compatibility are achieved. The Legacy 3 system expands treatment options by offering 6 diameters with a 7.0 soon to be added, as well as the 6mm lengths. All 3 fixture mounts offer options for insertion, including a hex hole in the top for engaging a 2.5mm hex tool or drill, which also fits into the internal hex of the 3.7, 4.2, and 4.7 implants, and a square top that accepts a screw vent or a Nobel BioCare fixture mount drill. The fixation screw for the 2-piece fixture mounts and the cover screw accept standard 1.25mm hex tools or drills. With a full line of internal hex compatible abutments offering significant savings, Implant Direct continues to broaden your prosthetic options. Visit the Compare Systems section of implantdirect.com to read about the limitations of the Zimmer TM implant. Coming soon from Implant Direct, the Legacy 4 with an innovative fixture mount. Watch the All Over 4 video on the Support tab at implantdirect.com to see the GPS and Legacy used in an upper edentulous jaw treatment.
So, there's been a lot of improvements brought to the market by Implant Direct, basically maintaining the compatibility of these popular systems, but bringing the changes that I feel these companies should have done to their own products. Let's talk about the search for clinical success, because we hear so much about research and studies and which implants got the most number of studies. Here was a study done in Spain by Dr. Pedro Pena and 5 colleagues, where they put Nobel Replace implants side by side with our RePlant implants. They put 4 RePlant implants in with 2 Nobel implants. They placed a total of 373 RePlant implants and 48 Nobel implants. They had 13% failure with the Nobel implants and 1% failure with RePlant. And they attribute that to the higher initial stability because they didn't need bone tapping because of the self-tapping threads. There's another article came out last year with 98% success with the RePlant reactive implants from Implant Direct in the maxillary sinus, which was the same success rate that this surgeon got with the Nobel implants. And again, he was mixing implants in the same patient. So the success rates are there. There's another study that came out a year ago by Dr. Cavallero from NYU University, using the SwishPlus implant, which is the same body as the Legacy 1 but with an external bevel. He had 99.43% success in healed ridges, 96.4% in extraction sockets, for an overall average of 99% success. Simple screw plant implant, lay a flap, insert the implants. There's the fixture mount that is a snappy abutment when it's cut off. Take off the fixture mounts, shorten the abutments, reseat them, snap on the transfers. They do not come with the implant, but a snap-on comfort cap does come with the implant. And here's the impression that picked up those transfers. Then you have abutment analogs that fit into those snap transfers. This is called an abutment level transfer. We're leaving the abutment in the mouth, and we're going to have an abutment replica on the working cast to complete our restoration. Here we have a temporary that was fabricated incorporating these snap transfers. This picture is taken from Zimmer's website, documenting 10 years of success rates with the tapered screw vent implant. Now, our legacy implants go in with Zimmer screw vent drills. They have the same type of blasted surface, same connection, made on the same machines, and developed by the same person. So I think this is direct relation to our current product line. 11-year results, 98.7% success. The search for the ideal implant design. We have a variety of designs that we'll be talking about with a variety of platforms. Again, some of them are launched to provide the users of Nobel and Straumann and Zimmer with compatible products. Some of them are unique products for specific clinical applications. The two newest implants are the SwishPlus implant and a new one that has not yet been launched called the Interactive, that has a Nobel Active compatible platform. It's basically the body of our Legacy 2 implant, which has been on the market for 3 years, but we added micro grooves and switched out from the 45 degree to a 78 degree lead-in bevel. It also has unique packaging, which I'll talk about. So there are a variety of screw implants. You have the Nobel Replace without a self-tapping groove. You have our RePlant, which has the same outside profile, so it could be inserted with Nobel Replace drills, but we've added the self-tapping groove and micro threads. You have the Nobel Active, a more aggressive screw implant. The threads are deeper, but they're wider apart, so you don't really add more surface area. Has a sharp apical end that can get off track as you're screwing the implant in, or tear the sinus membrane if it encroaches there. It has micro grooves compared to micro threads, which can add to stability. It tapers in at the top, which could potentially leave a gap at the crest of the ridge. When Nobel launched the Nobel Active, I came out with Reactive. I kept the Tri-Low platform. I didn't think that the Nobel customers needed to switch a platform just to get deeper threads. We made flat-based threads similar to a Straumann implant. The outside tapers at 1.5 degrees, depending on the length, 1 to 1.5 degrees, just like the Legacy 1 implant, just like the screw vent, but the inside threads taper at 3 degrees, giving you more thread engagement apically. Longer self-tapping groove halfway up the implant. Then the Interactive implant has 3 cutting grooves that go 2/3 the way up, just like the Legacy 2 implant that's been available from Implant Direct. Micro threads, and then we added micro grooves at the top. All of our implants have rounded apexes, just like the Nobel Replace. Micro threads, let me explain the advantage of that. We go from double lead threads, that's 2 threads starting at 180 degrees and wrapping around, so when you turn the implant, it'll drop twice as fast as normal threads would into the site. Then you merge with quadruple lead threads, and if you go from 2 to 4 threads, every other micro thread lines up with a pre-tapped thread in the bone created by the lead threads. And the alternate thread hits the crest of the bone thread that's there and cuts a new thread, adding stability. This animation will demonstrate that. So it's double lead threads at the bottom, represented by blue and red as it spins around. They look like the threads are 0.6 of a millimeter apart, but they're really 1.2. When you get into the neck area, the top 2.5 millimeters, it goes to 4 threads starting every 90 degrees. This is a screw plant with an external bevel and a long internal hex. I received a patent on the microthreads, even though Astra has a patent on microthreads, but theirs goes from single lead to triple lead, which means they need to be made shallower to avoid cross-threading. When you go from double to quadruple, you can maintain the microthreads at half the depth of the body, so they still provide some additional stability. Talking about different implant designs, we have the Nobel Active, which they recommend for experienced users. That's a euphemism for the darn thing may not work unless you're very good or very lucky. You really want implants that are simply easier to use and easier to use for dentists just getting started. 2 features of this implant that I take issue with. The cutting groove is facing counterclockwise. It's to help you to unscrew the implant when it gets jammed in the dense bone, and it does that if you try to insert it into dense bone because it flares so dramatically. And the apical end is very sharp, which can allow the implant to track in a different direction as you're screwing it in or tear the sinus membrane. So when you compare this to the reactive implant, which has the tri-lobe that comes on a fixture mount that's a preparable abutment, you can see the advantage. This also has platform shifting. Here's close-ups of the Nobel Active implant versus the reactive body, which is the same as the Legacy 3. This is a Legacy 3 because you can see the internal hex, a nice clean anodized internal hex. Compare that to the Nobel internal hex, and you can see burrs left on the implant from manufacturing. So high prices do not necessarily assure high quality. Comparison of the apical ends. Here is the Nobel Active with its sharp ends, its reverse cutting groove, very wide and deep threads. The Nobel Replace, where the threads blunt down to next to nothing and don't have a self-tapping groove. A standard V thread, 0.6 of a millimeter apart on the pitch. Double lead threads means that every other thread is contiguous. Cutting groove, that's on the RePlus, the RePlant, the Legacy 1 implants, and all the Spectra system implants. And then you have the reactive and the Legacy 3 implants and the SwishPlus that have these threads that get progressively deeper, increasing the surface area. Now, the greater the flare, the greater you're going to be compressing the bone, you think. But actually what happens is when you have real deep threads, the bone can squish into those, so you don't get as high a stability with a real deep thread as you do with one that is a little shallower, and I'll show you that in a chart shortly. So here's the difference between the reactive, where the outside tapers at 1.5, the inside at 3.5, versus the Nobel Active, which flares dramatically and then comes back. Here is a chart off of Zimmer's website where they compared initial stability. The tapered screw vent generated 119.9 Newton centimeters of torque to insert it into the bone model they were using. The Nobel Active was at 93 and the Nobel Replace was at 89.5. No significant difference here, yet one has very deep threads and is marketed as increasing stability, but it doesn't take much more force to screw it in than the Nobel Replace. The Straumann, which was tested, was half the stability of the tapered screw vent, only 60 Newton centimeters. So design does affect initial stability, which does affect clinical success and your ability to do immediate loading. Here's the legacy implant with its rounded end, used as what we call an internal sinus elevation. You drill through the floor of the sinus, push bone graft material up, tenting up the membrane, and screw the implant in. Nice round end there, and these are Nobel active implants, and you can see the sharp pointed ends near the floor of the sinus that would not be advisable in a procedure like that. You also see the tapered neck, which can leave a gap. This is from Nobel's literature. It says Nobel Active is a unique implant system. It offers experienced surgical restorative clinicians an enhanced set of options for cases involving soft and medium bone. So they're telling you don't use it in dense bone. You don't know what the density of bone is often until you get into it, so it's a little late to be ordering your implant then. The search for the ideal surface. This just shows blasted SLA from Straumann, which is sandblasted with aluminous oxide, followed by acid etching. Acid etching alone, which really flattens the machining grooves and ends up with a smoother surface than if they just left it machined. Ti-Unite, which is an anodized surface, creates these bubbles and pores on the surface that may not be able to be maintained if exposed in the soft tissue. The textured surfaces used by Zimmer BioHorizons Implant Direct are created by blasting with a soluble blast media like HA crystals. So you blast, you wash it, it's clean. The acid etched Straumann, you need to etch to get the aluminous oxide particles off, which tends to round the threads. Now Zimmer has come up with its new surface, trabecular metal surface, and primarily claiming a greater bone ingrowth, but the implant is straight until the bottom, a little 3 millimeters of threads. There's been an FDA recall, which just means they had to inform their customers to change their surgical protocol because this threaded end, which is added after the trabecular metal is added, can come loose. It's laser welded to the body of the implant. So there's reports of it, at least one report of it coming loose. To get around that, Zimmer recommended that in dense bone just use a straight drill. Well, that means that you've got a few threads at the top here. These are micro grooves. Then you've got a non-threaded section like a cylindrical implant. Then you have the apical threads, which are not going to touch anything because they're tapered and you're using a 3.8 straight drill. This implant, the smallest diameter it can be made in is 4.1, and it has a restriction not to be used freestanding in the posterior. I don't know why that restriction was needed in order for them to get FDA approval, but you have to question this implant if it can't be used in narrow ridges, if it has limitations to immediate loading, if it doesn't add to the stability, especially when the tapered screw vent has 98% success over 10, 11 years. The only justification I can see is that Zimmer adds about another $50 to the price of the implant. We did a lot of research on implant surfaces in the 90s, SBM and HA coated surfaces, different comparison studies at different universities, and we found that the blasted surface was comparable to the HA, at least initially. The other rough surface that was popular at that time was TPS. It's off the market, it's too rough, and then acid etching, which is too smooth. Here was a study, torque removal studies. That other one was a percentage of bone contact study. This is a torque removal study comparing acid etched, TPS, SBM, soluble blast media, and HA. At 1 month, these three rough surfaces were all comparable in torque removal, but by 2 months, the HA surface was twice as firmly attached. We sell a full line of HA-coated implants, and I recommend it in the soft bone situations. Here is our blasted surface on the microthread area and the HA, which is a very dense HA, 90% approximately crystallinity, and it looks just like the blasted surface. Here's a email I received from Dr. Gary O'Brien. I just uncovered a case with 16 Legacy 3 implants, and there was 0 bone loss in all 16. Very impressive surgical results. These are some of the photographs that I thought you'd like to see. This is by far the most user-friendly, forgiving, bone-loving design, implant design I've ever placed. And you can see the bone right up to the top of the implants. Here's an email I also received from an opinion leader for Nobel, or at least he was an opinion leader until he sent this out to 2 Nobel salespeople and myself. And he said, "Hi guys, here is unfortunately a typical example of what I see too often with the replaced design. Pass these along if you like. I have not made any attempt at a comprehensive analysis, but I would estimate that at least 25% of my cases are showing unacceptably high degrees of early bone loss." And here was a follow-up of these cases, from the healing collar to the abutment attachment, and back here was a time of placement. So healing collar, a couple months later, and the abutment attached, and similar results here. So there is some question about the Ti-Unite surface, whether it contributes to this or not. Companies are looking for the holy grail to preserve crestal bone. Really, the most important thing to preserving crestal bone is have adequate thickness on the labial plate. A study was done in the early 90s that I funded. It was the largest study ever undertaken in dentistry, let alone implants. 3,000 implants, 1,000 US veterans, and they placed implants of mine of different surfaces. And when they drilled the surgical site, before they placed the implant, they measured the labial plate. Then they put the implant in. When they uncovered, they measured bone loss. And at uncovering, you were seeing a direct correlation of bone loss to the thickness of the labial plate. If you had a 2 millimeter thick labial plate, you never lost any bone. If it was 1 millimeter, you'd lose about 1 millimeter. If it was thinner than that, you'd lose up to 2 or 2.5 millimeters. Nothing to do with platform switching or the attaching of the abutment later. That bone loss was occurring while the implant was submerged, merely because the ridge was thin. Now you can solve that problem to a certain extent. You can use smaller diameter implants. Don't push it with the widest diameter implant. You could flatten the ridge to create a wider platform. You could split the ridge and you could do bone grafting. Or you can just accept 1 millimeter or so of bone loss because it won't affect the clinical results. Here we have Astra with their micro threads claiming reduced bone loss. You have Nobel with their micro grooves, and then you have BioHorizons with their laser lines. And they have 8 micron laser lines for the soft tissue and 12 for the bone. Well, who's to say the bone won't be scalloped and part of it will be in the tissue or part will be in the bone? And here is a study comparing human gingival fibroblast cell adhesion and proliferation to grooves of 15, 30, and 60 microns. And what the study showed was, this study indicates that titanium substrata with etched micro grooves, 60 microns in width and 10 microns in depth, significantly enhance human gingival fibroblast adhesion and proliferation. This is why we put 60 micron grooves on our new interactive implant, so that if the top gets exposed above the bone, then for those of you that want grooves, you'll have grooves of the right dimension. The search for the ideal connection, and that's a big differentiator in the implant industry. Implant Direct offers a variety of platforms. We have the lead-in bevel, which is on the legacy BioHorizons, Screwvent, MIS, most of the Israeli clones. Every country, in fact, makes a copy of this Screwvent connection. In Europe alone last year, 3 new companies started with this connection. Then the trilobe, the internal octagon from Straumann, but we've added a square so that you can engage it with the tool to screw it in, so you don't need a 2-piece handle to stabilize when you're removing the fixture mount, as you do with Straumann. And then we have an external bevel, which acts like a ferrule effect and directs the forces in. This was the first one that Implant Direct made. I have a patent on a trilobe. I got around Nobel's patent by putting double grooves in. Their patent calls for these 3 micro grooves, a cylindrical unthreaded section, and then internal thread. So I just extended the grooves all the way down to take full advantage of the length for increased stability. Now our fixture mounts for the RePlus and Reactive engage the full depth of those grooves for increased stability, but all of our abutments only engage the top ones, so they're compatible with Nobel. Nobel has come up with 2 new implants. This one is their platform shifting. So all they did is step down, use one smaller size platform. They use the 3.5 platform on the 4.3. They use the 4.3 platform on the 5. And it can get very confusing with their color coding because the same abutments are used. Then they also put the Nobel Active conical connection on a Nobel Replace implant. So they've just added 2 more implants that really don't add anything to the clinical success of the case, just to meet the demand of different dentists. Here is our interactive implant with the micro grooves. Here is a 3D picture. You see the 3 cutting grooves, the round apex, the long cutting grooves going 2/3 the height up, the conical connection, color coded to match Nobel's colors, and the micro grooves. And it'll be available in 4 diameters, 3.3 and 3.7, which will have the same platform, 4.3 and 5. Nobel Active requires that you take x-rays to see if the abutment is seated, because it has this long bevel, and just looking at the implant you can't tell if the bevel is all the way seated. On their transfers they put a groove there now so that you can see it, but they can't put that groove on the abutment. So if the screw engages before the hex is seated, you don't get this seated, and your transfers won't work, and your restorations won't fit. We've tried to solve that problem with our interactive abutments by making the hex longer and the bevel shorter, so you can clearly see if it's not seated, the hex will be above the crest. We still have the same angle on the bevel, so that this will fit Nobel's implants and ours, but it'll be easier to identify whether it's seated. We also added a little extension here that fits down into this part to straighten it up, and we put internal threads inside the abutment so that you should really seat the abutment first by rotating and feeling that it's seated, and then tighten your screw, and then the screw will come out of the abutment and into the implant. So that's how we've tried to solve that problem. Again, with continued design, quote, innovations to differentiate products, you have Dentsply has now bought Astra. I think they paid over $1 billion for Astra. They also have the Ankylos product that they bought. And Astra, to differentiate their product, has come up with a profile top on the implant. Well, Nobel used to have the Nobel Perfect with the double profile. It's now obsolete. You can't even buy it. It was brought no clinical advantages and had complications, so it's off the market. You can still buy abutments for it. So Astra's now got half of a Nobel Perfect implants. This is the Astra implants. They're generally straight implants with micro grooves, nothing spectacular. They do have one version with a flared neck, and that's the one that they've put the slope top on. Now, when you have this long conical connection and a flared neck with very thin walls, guess what happens when you overload the implant? Tighten down this abutment wedge, forces go outward, and what happened here is the wall of the implant broke, and there it is floating right there, and so much for microthreads stopping bone loss. You can see how thin that wall is on the cracked implant. That was given to me by a dentist. Another thing to look at is the abutments and how much torque does a company recommend you tighten the screw. This is a very critical matter. Nobel Active came out with a 3mm implant, but they warn you do not tighten beyond 15 Newton centimeters. They got a little screw in that implant, and it could strip or fracture. They're angled abutments, angled screw receiving abutments for teeth in a day procedures, also 15 Newton centimeters. Astra has 15, 25, 20. Who wants to figure out which torque you should apply depending on which abutment you bought? All of ours are 30 Newton centimeters. Apply the force and the abutment will stay in place. Now, this is Dentsply's ankylose implant versus Dentsply's Astra Profile platform. They now are selling competing implants with competing theories. The ankylose, which is a Morris taper, that means a tap-in press-fit connection, requires a long run to the abutment till the abutment gets to the height of contour. And as a result, you have to drop the implant below the crest of the bone just in order to get the height of contour of the abutment below the crest. So this implant advocates positioning below the crest of the bone. Now Astra comes along, now owned by Dentsply, with a profile top implant, and it teaches something different. Here's the ankylose below the crest of the ridge, and this, I just simulated this to show what it would look like if you added 2 more millimeters to the implant. You'd get a better emergence profile. You'd preserve contact with probably the best quality bone in the ridge right at the crest. So they're not saving bone, reducing bone loss. They're giving up on all this good bone contact. Sometimes you need to create a countersink in the crest just to get the abutment seated. And another case with ankylose, again, look at how far below the crest of the ridge that is. A better solution would be to add 2 millimeters onto the implant and take advantage of all that good contact and then have a normal emergence profile. So Astra justifies this profile implant this way. They say, well, you'll get a scalped ridge sometimes where some of the implant's exposed on the labial. I say don't worry about it. What does it matter whether the first millimeter or 2 against the soft tissue is the surface of the implant or the surface of the abutment? It doesn't really matter. Now you can avoid it by flattening the ridge using smaller implants. One of the reasons you get this scalloping is this implant flares out. So you need to make a bigger hole to accommodate that implant. And so they say, well, you know, it gets exposed and you don't want to put the implant farther in the bone to be level because then you'll have this bone projecting above the implant, which is exactly what ankylose tells you should do. That's the same company telling you to drop the implant below the crest. So that's the justification for a contoured implant innovation. The solution would be leave the labial exposed, use a narrower implant so you didn't scallop, reduce the crest of the ridge on the lingual if you didn't want it projecting above the implant. We have crestal bone drills that when you turn it forward, it widens the crest, which is the densest bone, to the diameter of the implant. And when you turn it in reverse, it plateaus and flattens the ridge. So we have drills just to do that procedure, flatten it. But if you didn't flatten it, what does it matter? So you'll have bone growing over that bevel. Since the abutment is fitting on the internal conical connection, You wouldn't want bone growing over it if the abutment was hitting the outer periphery. You wouldn't be able to seat the abutment. So this is the justification for this contoured profile implant, and I think it really brings nothing to the table, just adds complications. I've seen cases where they use that in the lower posterior, where if the ridge dips down, they'll use this profile, rotate it so the lower part is to the mesial to follow the profile. I guess they're worried about molar papilla aesthetics, which is something that I never really worried about in my practice. Implant prosthodontics, that's the name of the game. You need to look at the restorative components of a system. Do they meet your needs? Are they strong? Can you tighten the screws down? Do they fit well? So we have the widest variety of abutments in the industry. We now have zirconia abutments on metal bases, luted to metal bases. They come straight 8 degrees and 15 degrees, or you could just buy the base, and the labs will make custom zirconia abutments. We developed an implant abutment like the locator, except that we call it the GPS, and we have our own attachment called the GPS attachment. We have an internal and external attachment for that. So here is the internal GPS attachment, and we've found in tests that when you tip this 10 degrees, it'll initially hold 100% of its retention, whereas the Zest loses 27%. We developed an implant abutment like the locator, except that we call it the GPS, and we have our own attachment called the GPS attachment. We have an internal and external attachment for that. So here is the GPS attachment. It comes provided on a carrier that is a transfer. Each abutment is provided with a snap-on comfort cap, a nylon liner, the metal housing, a black processing cap, and a spacer. Significant price savings compared to the competitors. We also sell GPS kits that is the metal housing and 3 different retentions of nylon caps. The black is used for processing. The spacer is used to keep the processing material flowing over the model, or if you're doing chairside relines. This is the internal connection, which is a ball that snaps through the opening. Our metal has added retention. It's anodized pink. Our abutments use standard insertion tools. If you're using Nobel, it uses their unit grip. We have created a deeper internal cavity for vertical displacement of that ball. We do offer 2 liners. The internal one, as you see here, and an external one that rotates. The nylon and the metal housing rotate together over the rounded top of the abutment. This one we're recommending primarily now for bar overdentures where rotation is not really needed and where we can get these parallel, because if you're just using freestanding implants, the internal one, which now comes packaged with every abutment, has the added advantage of vertical stress braking. You can see the plastic will push out of the way, allowing that ball to move up and down. And of course it rotates. Compare this to the Zest, which has a curved inner surface to the metal housing and a convex outer surface to the nylon. So these two pivot on each other, and the metal rotates around the nylon in function. Now, if you place 2 implants and they're not parallel, the way to handle it is in the lab, you just straighten up the housings, just like you would on a ball abutment. Straighten them up before you process it, and they'll snap over the circumference of those attachments. It's relatively easy to get these within parallelism. In function, the denture base seats on the soft tissue posteriorly. This will move up and down and rotate. We also have 15 and 30 degree angled GPS attachments, something Zest does not have. These need to be indexed with the flat of the hex on the implant at time of placement facing the mesial, or the trilobe facing the mesial, because this will tip. Usually you place these implants at an anterior posterior angle, and this will straighten them up. A nice procedure, you've heard of all on 4. This is all over 4, where you use a snap over denture. It provides total implant support and retention. We have the Go Direct implant, which provides the same platform that can be used in combination with the angled implants and angled GPS abutments on the distal. This comes with a transfer and snap comfort cap as well. So that's the GPS system. I've written an article on it. It's available on our website and in reprint form. This shows the abutment that we just talked about, the angled abutments, the external attachments rotating, and the internal one, the ball that moves up and down. This is very similar to a 1983 patent on the core vent attachment that was so very popular for stabilizing dentures. Just instead of a spacer there to hold the nylon up when you processed it to the denture, it's held up by these two corners. This shows the variety of zirconia abutments that we have. Here's a picture. You can see the precision of this zirconia to the metal base. Now you can have custom zirconia abutments made, but they're going to cost 2 to 3 times as much as this. Other companies make zirconia stock abutments, but they're usually all zirconia with the screw tightening down on the zirconia. In the case of Nobel, they make one with a metal liner, but the screw still tightens down on the zirconia, and those are more subject to fracture. Here's a case. We sell a preparation kit to prepare these zirconia abutments. Search for the ideal packaging. The interactive led me to a new packaging that I want to show you. And again, we have an article on it. This one will have a concave underside coming out of that conical connection, and the fixture mount that the implant's provided on is a 2-piece fixture mount that has significant advantages. And I'll show you the video on this. So here's the fixture mount on the interactive implant. This same fixture mount will soon be available on the Legacy 2, and we're going to be calling it Legacy 4. 2-piece fixture mount, retained by those little arms, snaps into the abutment portion. The abutment portion has an internal hex, so if the fixture mount is too high, you can just go in there with a 2.5mm hex tool. That score line demarks That score line marks where the internal hex stops and the channel becomes narrower. There's your conical connection. Three cutting grooves, progressively deeper threads, micro grooves. Package comes with a 2mm cover screw, broached for both Nobel, Straumann, and our tools, triple broached, and a 2mm healing collar. The top of the fixture mount is split so that it provides retention when you snap it onto the fixture mount. It won't fall off the ratchet, and it's grooved so that it'll provide retention with the ratchet. You can also put a 2.5mm hex tool inside it. If that tool has an O-ring the way we make it, you can pick it up and carry it that way. Index the implant, put the flat of the hex facing the index the implant, put the flat of the abutment portion facing the labial, and that will orientate the flat of the internal hex of the implant. This means that when you order an abutment with a contoured margin or an angled abutment, it will align appropriately. Now you can insert it by just putting the hex tool into the top of the abutment as well, if there's limited opening. The two-piece fixture mount gives you the advantage of having the accuracy of an open tray transfer with the simplicity of a closed tray. An open tray transfer would have a hole in the top, and you would then unscrew the transfer in order to remove the tray. That some people believe that's the most accurate type of transfer, but a closed tray, you just snap the part back into the impression later, which is the most common way of doing it. There's your 2mm healing collar and color-coded cover screw. Attach the abutment to an implant analog. Now, when you snap it in place, it's metal to metal, and you'll hear the click. Know that it's fully seated. Pour up the impression. You could shorten the abutment if you wanted to the score line. That'll give you a smaller hole at the top, screw access hole. Or you could block out the undercut if you needed the longer length of the abutment. Put some Vaseline on that wax before you waxed up your coping and made your final restoration. Remove the cover screw and healing collar. Seat the abutment using 30 Newton centimeters of torque. And seat your restoration. That's the interactive implant, and that fixture mount will be available on the Legacy 4 as well. So these pictures just show what the video was showing, the transfer procedures, preparing the abutment. Now, Spectra system was the first system I launched, and it had 6 implants, all with exactly the same body, but with different platforms or packaging. The SwishPlus 2-stage implant, external bevel, the SwishPlus flared 2 millimeters, like a Straumann implant, like our SwishPlus SwishPlus implant, a one-piece implant, 1.5 millimeter high neck, external bevel, the same as on these implants, with a 5.5 millimeter post and a retentive groove. The screw indirect, 3 millimeter high neck, 5 millimeter wide platform, multi-unit abutment with a retentive groove, which allows me to give you a snap transfer and snap comfort cap. We even have a 12-degree angled one-piece implant with a contoured margin, and the Go Direct implant with a locator compatible overdenture abutment. Here's the one-piece Screw Direct implant, comes in 4 diameters and 3 lengths, packaged with a snap-on transfer and comfort cap. 2 of them were placed 7 years ago and joined with a cantilever pontic. Single tooth replacement using the one-piece implant. Seat the implant, comes on its snap-on transfer. Use that transfer to take the impression, as you see here. You can then temporize the abutment. You then have an abutment analog and a castable coping that will allow you to fabricate the restoration indirectly while the abutment is still in the mouth, supporting the temporary restoration. So here we have the Go Direct 3 implants in the symphysis, or the Screw Indirect 5 implants in the symphysis. I recommend 3 with this because the middle one will give you indirect retention. Otherwise, you're teeter-tottering on the 2 distal implants. As the denture base tries to come up, it would seat on the anterior one and be more stable. All-in-one packaging is unique to Implant Direct. Here's the packaging for the Screw Indirect. Comes with a healing collar, extender, comfort cap down in this, and even comes with a white transfer. If you use the extender, use the white transfer to tell the lamp to use the appropriate analog. And this is the all-in-one packaging for the Legacy implant. Comes with a fixture mount that needs to be cut off to turn it into a preparable abutment. Comes with the cover screw and healing collar as well. We have wide, narrow, and short implants. 7 millimeter wide Legacy 2 implant for placement in molars and in molar extraction sockets. 6 millimeter long implants that will soon be launched, and narrow 2-piece implants, 3.2 millimeter implants in the Legacy 3 series. Here's 5 small diameter implants. The Screw Indirect, the Go Direct, the Mini Go Direct with a pointed apex, and the Screw Indirect implant all come in 3 millimeter lengths, and then the 3.2 Legacy 2 implant. Implant Direct will be launching CAD milled bars and custom abutments, and we have a full range of biologic materials as well. This is a robot and 2 machines for making CAD milled abutments, so we're going to be offering that at a more reasonable rate after the first of the year. Here are 2 bars that we've made, and this just shows how these bars are designed on software. Legacy 1, 2, and 3, that's our biggest selling implant right now. Legacy 3 is our broadest selection of implants right now, from 3.2 to 5.7 every half millimeter. This shows the 3.2 Legacy 3 implant. It has a double hex in the top, because we went with a smaller diameter main hex, 2 millimeters instead of 2.5, a smaller screw in order to maintain the wall thickness for strength, but then we needed that double hex to be able to apply adequate torque. This is the Legacy 2 4.2 implant. Same 3.5 platform, 4.2 neck diameter for platform shifting. 3 cutting grooves that go 2/3 the way up, and more aggressive threads. Comes on a fixture mount that is a very good transfer. It could be shortened to be a temporary abutment. There's the packaging, the fixture mount, the cover screw, the healing collar. And this shows the Legacy 3 next to a Legacy 2. So just deeper threads on that implant. Here's the Legacy 2 fixture mount, which can be shortened to be a temporary abutment, or the Legacy 3, which is a fully preparable abutment. This chart shows torque strengths. When you go into balsa, which simulates soft bone, with a 4.2 implant and you're using a 3/4 drill, not the 3/8 that would be recommended for dense bone with that 4.2, but a 3/4 drill that steps down to 2/8, you can generate 45 Newton centimeters of torque for a Legacy 2. Using the same protocol and the same diameter Legacy 3, you actually generated 59 Newton centimeters. So you'd say, well, gee, the Legacy 3 gives you better initial stability. But the Legacy 2, being so aggressive self-tapping, you can place it into soft bone with a 2.8 drill, 2 sizes softer, and generate up to 102 Newton centimeters of torque. So you can really do everything with the Legacy 3, but the Legacy 2 is a very popular implant because it'll self-tap in dense bone easier. You won't have to go to the dense bone drill as often to insert this implant, and it's less expensive. And if you're going to be buying an abutment for it anyways, then you don't need the Legacy 3 abutment fixture mount. Here is the 7mm Legacy 2 implant. The bottom is a 5.7 implant and the top flares to 7mm in diameter, with the same platform as a 5.7 Legacy implant. Here's a case placing the implant, used in the sinus area where we need a short implant and a wide implant. Here it is again in the maxilla for added stability between the buccolingual cortical plate. This molar is going to be extracted, so before the dentist extracts it, he establishes the trajectory he wants for his 7mm implant, going through the septal bone, then takes out the tooth and prepares the rest of the socket and seats the implant. Here's immediate extraction of this implant, waited for the bone graft to heal, placed the implant. The fixture mount is used as a temporary abutment. There's the temporary restoration to establish good emergence profile, and seated the final abutment, which was a snappy abutment, and completed the restoration. Replacing a lower molar with 2 implants is possible also, merging the 2 abutments. So we have short implants, we have long implants, we have wide implants. Implant Direct has a full range of products. Our short implants have 102 square millimeters of surface compared to only 68 for Straumann's, or 78 for Bicon, which advertises itself as the short implant. And narrow implants, I'll show you some cases with the 3.2 implant. This dentist using an endodontic file to identify the trajectory, goes right through the tissue with the drill, opens up the tissue with a diamond, prepares the site, seats the implant. There's the fixture mount, uses that as the transfer. There's the internal hex blue interface of the 3.2 Legacy 3 implant, puts the cover screw and healing collar on that come included with the implant, After preparing the fixture mount, there's his abutment and the seated restoration. This is just comparing the round end versus the sharp end of the Nobel Active implant. And more on the interactive implant. We now have the Go Direct with a pointed end. The Go Direct first came out with a round end in a 3, 3/7, and 4/7 diameter implant. Here was an article that I had published talking about the new Mini Go Direct with the pointed end. And this implant has internal threads, so it can take a variety of other abutments. I'm going to show you a video now that goes through these procedures in great depth. This is showing the 3mm Go Direct and Mini Go Direct implants. They do come in different collar lengths. So one has a pointed end, the other has a rounded end. They both have double lead threads for faster insertion. They both have micro threads for reduced crestal bone stress. They have either a 1.5 or 3mm neck on them. The one with the rounded end is straight and then tapered, whereas the one with the pointed end is evenly tapered. The one with the rounded end just comes in 3 lengths and 3 diameters. They both come with an internal set screw that can be removed so that you can add a multi-unit or a ball abutment to it. You could add another GPS extender or a custom cast abutment to it. So it's a one-piece implant that can be converted into a 2-piece. Now Zest came out with an implant that tries to copy this. It doesn't have the micro threads. It sticks up 1 millimeter higher than ours. So it doesn't have an internal thread to give the option of adding other abutments. There are 2 options for placing implants in narrow ridge. Either lay the flap or to do the procedure flapless. So let's look at the standard flap surgery, which is what I recommend for most situations. It gives you the opportunity to flatten the ridge as necessary. This is for the 3mm Go Direct implant, 13 millimeters in length. There's the 13mm line on these drills, and this is a crestal bone drill for very dense bone, and when you turn it in reverse, it'll flatten the top of the ridge as well. So select the 2.3 step drill. Make your initial pilot hole. This is for placing 2 implants. Penetrate to the full depth of the drill with the rounded Go Direct implant. If the bone is soft, you could stop at that point with the 3mm. Insert the paralleling pins. Use them to align the other implants, just as you're paralleling preparations in the mouth. They need to be within 10 degrees of parallelism. If they're canted out, straighten them up with your next drilling procedure. You're going back with a 2.8 drill in dense bone, you could use that to straighten up those sockets. The attachments will work with 10 and 10, which is 20 degrees divergence, but there may be more wear on them, so it's easier to just get them parallel. So here is the Go Direct. Comes on a carrier that is a snap transfer. Just start its insertion, put the tool in and ratchet it to its appropriate depth. You have a 1.5 millimeter collar, which is usually the thickness of the soft tissue. If you need to leave it sticking up a little bit more, you could. Now, flapless surgery, you need to establish whether you have available bone. So you can measure the thickness of the tissue, and then you can map the bone with probes, or better yet, do a CT scan and determine whether you have available bone or not. Much more difficult procedure to do this than laying a flap. Do your tissue punches. Start with a locator pointed drill. In soft bone with the pointed implant, you only penetrate half the depth of the drill. So there's your locator pointed drill. For expediency, cut all 3 initial pilot holes. Select the 2.3 drill, it steps down to 2. In relatively soft bone with the pointed implant, you can stop halfway down and the implant point will work its way through the bone because of the sharp end. If the bone is dense, then go ahead and finish the site to the full depth. If you attempt to place a pointed implant in dense bone that's only been prepared half the depth, there's a chance of fracture. Put the paralleling pin in and then repeat the procedure to help you line it up. That's how you work your way around the arch. I recommend using 3 of these implants in the edentulous jaw. The middle one will give you what is called indirect retention. And again, try and get them within 10 degrees of alignment. If they're off, then it'd be a good idea to straighten them out with your next drill. In the case of the pointed ones, if you've only penetrated halfway, you could use the same 2.3 drill and just finish the depth of the preparation as you realign the implant. Take the tag off of the implant, put it onto your patient record. This is a 3.0 millimeter mini implant, mini Go Direct implant. There's a snap comfort cap also packaged with that. Just turn it with finger pressure and then ratchet it to place. Now, if the torque seems to be getting too high, and I recommend using torque ratchets, above 70 to 80 Newton centimeters, stop and back the implant out and then penetrate to the full depth with the drill. If you determined the density of the bone properly to begin with, you wouldn't need to do this. You would know whether it's dense, and you would have taken care of that at the beginning. If you now find out, though, that it is too dense to get it fully seated, then come back with the 2.8 drill and might as well penetrate to the full depth of the drill, to the 13 millimeter line. There's the three of them. The anterior one will provide indirect retention when the denture tries to pick up in the back as the patient's chewing. Snap on the comfort caps. Deliver the patient's existing denture with a soft liner. You see there are two neck lengths, 1.5 and 3 millimeters. That's 13. This would be to the 14 and a half, which is halfway between 13 and 16. And this 1.5 millimeters must stick above the soft tissue for the attachment to snap on. Now you're ready to take your impression. Snap on the transfer that comes with the implant. If you want to cut it off to make it shorter, you can. Snap on your comfort caps. Now you put the abutment analog in the transfers. Pour the working cast. Here's the attachments. They come with a black processing insert and liners with different degrees of retention. This shows the internal attachment, better retention than the Zest, anodized pink, a space in here for this ball to move up and down. This is the internal liner. It's recommended in a lower edentulous jaw with 2 to 3 implants. Here's the external one, which is what we use on bar overdentures now, where we're sure to get these parallel and where we don't need vertical stress breaking. It will rotate. So we've got the external and we have the internal. Attachments usually come with the 5-pound retentive one. And you can see how this moves out of the way and allows the ball to move up and down. And rotate. Metal housing and the black insert and the spacer are used for either a chair pickup in a reline, or in this case we're going to manufacture a base plate, stabilized base plate to take the bite registrations. Mount the working cast on an articulator, set the teeth up for a wax try-in. Come back and check the aesthetics and occlusion of that denture base. Process the denture, and then you can remove the black insert and pop in the final one. Check the occlusion. You can also do this chair side using the patient's existing denture. Create space for the attachments. Put some cold cure acrylic on the top, seat the denture, and allow it to cure. You then replace the black insert with the nylon one. There's a special tool for doing that. And that's how we do overdentures. Here's a study done at the University of Manitoba, Canada, where they've been putting 3 of these in the symphysis, have yet to have a single implant failure. And this has become standard procedure, 3 implants in the symphysis to stabilize an overdenture. Here's a case using 4 of the 3mm implants. Laid a flap. This is the suturing, the comfort caps. There's the 4 implants. Here's a case that was done flapless, placing 4 implants. And here is Zest's attempt at copying the Go Direct. They have a cuff that screws on. They sell it as a single unit, but you could take that off, but it doesn't allow you a variety of different kinds of attachments, and they market it as being a lower profile than the ball attachment, but yet it is 1mm higher than our attachments because of this projection, and it doesn't have the capability of adding different abutments. There's a video that we have, I won't show it now, called All Over 4, where we place 2 Go Directs, 2 implants at an angle with angled screw receiving abutments, with angled abutments that come in 30 and 15 degree that you can screw in a GPS top into for All Over 4. Here's the 2 Go Direct implants in the anterior, or they could be 2-piece implants with GPS abutments, putting in the angled base, screwing on the GPS platform, the 4 attachments are then attached to the patient's existing denture or transfers. And here's a case using 4 implants and GPS attachments. Another procedure is with the screw indirect implant. Let me show you the packaging on this. This implant comes on a orange carrier that is a transfer. Also in the package is a white transfer, a snap-on comfort cap, and a 2mm extender in case the tissue is thicker. Now, if you use the extender, then you would use the white transfer to let the lab know what analog to use. So that's why it comes packaged that way. I'll show you some cases with this. So here is the screw indirect implant, 3mm widening to 5. It comes in 3/7 and 4/7 and 5/7 as well. 5 different copings that attach to it. Gold, titanium, plastic and gold, and a titanium temporary cylinder. These can be 40 degrees divergent and you can still seat the bar. So here's a jaw, lay a flap, place the 4 implants, snap on the comfort caps and suture. After it's healed, snap on the transfers, or you could do it the same day you place the implants. And here's the implant sticking above the crest of the bone. That's where the crest of the bone is. And this close-up shows you what a nice transition with a one-piece implant. Why put an implant and then attach an abutment when you can have it all in a one-piece implant without any junction between the abutment and implant? And this was a gold bar with attachments on the distal. Here's another case, extracted the teeth, put 5 of these screw-in direct implants in, attached titanium cylinders, take the patient's existing denture and drill holes in it and slip it over these and attach it with a cold cure acrylic, 4 teeth in a day. And there it is, these titanium cylinders attached to the patient's existing denture. Here's a case with a very thin ridge. The dentist placed 5 of the 3mm screw-in direct implants. You can see how thin the ridge is. He really should have flattened that ridge right to here and not wasted the time and money with bone grafting. He had a mountain of bone that he could have placed those implants in. Then you attach these titanium sleeves. You mark on the denture where you need to drill the hole. You lock these sleeves into the denture with cold cure acrylic and make a temporary restoration that you can deliver the same day. So this is what he started out with, and these are the 5 implants. There was a mountain of bone below that he could have dropped the implants. Another case with 7 screw-in direct implants, made a surgical guide primarily just to locate mesiodistally where he wanted to place the implants. This time this dentist flattened the ridge, initiated the placement of the implants, placed 7 implants. 5 right here would have been adequate for this case. 2 more are even better if you have available bone. Suture, wasn't trying to cover over him, just sutured to oppose the tissue. Then he used blue mousse in the patient's existing denture to seat it and to locate where to drill his holes to convert that to an immediate restoration. Seated the denture, trimmed up the flange of the denture, and delivered the case for teeth in a day. Here's a more sophisticated approach with surgical guides, 6 implants, snap-on transfers, and in the upper 7 of these with the surgical guide. The RePlant implant, which is surgically and prosthetically compatible with Nobel's Replace implant. We have a patent on a double tri-lobe, which allows me to duplicate their platform without violating their patent. Here is a Nobel Replace right next to a RePlant, placed with the same surgical instruments, Nobel's or ours. We provide ours on a fixture mount that can be cut off and used as a temporary abutment or a transfer. Comes with a cover screw as well. Here's our surgical kits. Here's a Nobel Replace next to a screw plant. This is 3.5, this is 3.7. Nobel comes with a warning, do not exceed 45 Newton centimeters, and if you do, the result is that you can fracture the implant and have to cut it out. All of our abutments for Nobel are double broached to accept Nobel's Unigrip tool as well as our 1¼ millimeter hex tool. That's all this is showing. We also have a RePlus and Reactive implants, which is the body of the Legacy 1 for the RePlus and the body of the Legacy 3 for the Reactive, but with tri-lobes. So we went to 3.7 and it comes back to 3.5 and you get the platform switching effect. So here is the RePlus implant. Comes in 3 diameters. All in one packaging with a fixture mount that can be shortened to be a snappy abutment. And you can see the outside diameter is 3.7 to a 3.5, 4.7 to a 4.3, and 5.7 to a 5 platform. So basically this goes in with the Zimmer drills or the Legacy drills, but gives you the Nobel platform. And here's a case, 2 of them being placed. They're HA coated. Fixture mount can be cut off and be a snappy abutment. There's the abutments created from shortening the fixture mount. Snap comfort caps that come with the implant. Snap transfers. Take the impression, complete the case. Here's a reactive implant that comes with the more aggressive threads and a fixture mount that's a final abutment like the Legacy 3 implant.